Okay, so we are on section 2. And so we're going to talk about really the simplest kinds of organic compounds, and those are alkanes. And alkanes are they're they have single bonds, right, between carbons, and so they're composed of all carbons and hydrogens. But every single bond in the entire molecule is a single bond. So we see a lot of these alkanes in fossil fuels, the things that we use to run our cars and things like that. And so we name these similar to how we name covalent compounds in general. We have prefixes that are specific for them. And so if you have only one carbon and then it's surrounded by hydrogens, right, you are called methane. And so that prefix is your meth. And then the ane is telling you that it's an alkane, that it's all single bonds, so that you can look at the name and then know what the formula is going to be, right? So remember your little mnemonic device for remembering those first four. It's methane, ethane, propane, butane. And I say me eat peanut butter. Methane, ethane, propane, butane. Okay. And then the rest of them are just like covalent compounds. So it's pretty, these are like covalent prefixes, right? So if you learn that, you're good to go. So remember that they all have this particular formula where you look at the number of carbons, right? And you put that same number of carbons by the hydrogen, you multiply that number by 2 and then add 2. And that tells you how many hydrogens you have. So you can always use that formula to go back and forth, right? The other kind of alkanes are cycloalkanes. They're similar in that they are all single bonds and they're all carbon and hydrogen, but they have rings, right? And so you actually make, it almost kind of looks like triangles and hexagons and all those kinds of things, right? And so these have a particular formula as well. If you count up the number of carbons, you know how many hydrogens because you take that number of carbons and you multiply by 2, and that tells you how many hydrogens you have. So you can kind of just look at a formula and know what it is. Okay. So 4.12, name the straight chain alkane or cycloalkanes whose structure or formula is shown. C2H6. If you look at C2H6, how are you going to get two carbons, and then you need 6 hydrogens, 1, 2, 3, 4, 5, 6 hydrogens attached to that carbon. So you're going to name this one the 2 carbon. So if we look up here, we have 2 carbons right here, C2H6, so that'll be ethane. Okay, whoa, I think I went too far. Yeah, here we go, ethane. Okay, now we can look at B and we can start counting our carbons. Remember, a carbon's kind of like a point, but you don't have to start at any particular place if there's nothing on that chain. So we go 1, 2, 3, 4, 5. We have 5 carbons. So this would be pent, right? Like pentagon, pent. And then it's ane because we have no double bonds, no triple bonds, nothing else. And it's a circle. So we're going to call it cyclopentane. Now, C4H10. If I put 4 carbons in a row, 1, 2, 3, 4, right? And I have 10 hydrogens. Can I keep it in a chain? That's 3, 4, 5, 6, 7, 8, 9, 10. Perfect. I have a straight chain. So it's not a cyclo, it's a straight chain. So this one would be butane, right? Me eat peanut butter. 4 is butter, butane. Okay. All right, let's see. Now we need to write the condensed structure for the straight chain alkane shown. So all of these are no circles, nothing like that. Okay, butane. We just said B, butane was butter. That's 4. Me eat peanut butter. So that's 4 carbons. Octane, you should remember your prefixes. That's 8. And then hexane is 6. But we want the condensed structure, not the molecular structure. So condensed, we're writing the C's and the H's. So we're going to do 1, 2, 3, 4 carbons. And we know that that first carbon is only bonded to one other carbon, like right there. So it needs 3 hydrogens. The second carbon here is bound to 1, 2. so it needs 2 hydrogens. That third carbon's bound to 1, 2, so it needs 2 hydrogens. And that last carbon is only bound to 1, so it needs 3. Okay, so B, octane. So 8, 1, 2, 3, 4, 5, 6, 7, 8. What's really cool about a straight chain is that the ends are going to have 3 and everything else in the middle is going to have 2. So it's really quick and easy to go ahead and fill them in. Okay. C, hexane. 1, 2, 3, 4, 5, 6. 3 on the ends, 2 for everybody else. Pretty easy, right? Okay, now we go to structural, our skeletal structures here. All right, so write the skeletal structure for the alkane or cycloalkane shown. So it could be either or. What you need to do is kind of look at this formula and say, if I have 4 carbons, right? See, what formula does this fit? Does this fit my N, H2N plus 2? Does that fit this formula? If I have 4 times 2 is 8 plus 2. Oh, it's not that. So it's not this one. So it must be CnH2n. And so that tells us that we have a cyclo, right? You have to remember those formulas, or you can just kind of draw them out, right? So if I'm going to draw a skeletal structure, if I have 4 carbons, it's basically a square. And I have 1, 2, 3, 4 carbons. The cool thing about this, which you're not going to, don't draw your labels, right? That's A, is that I don't have to draw my hydrogens. So I just draw a box and I'm done. Pretty nice, right? So that was just the structure, but let's do B. Okay, so B, I have, let's see how many that is. 1, 2, 3, 4, 5, 6. Okay, so this is a hex, right? It's hexane or cyclohexane. So you got to think about it. Which one is it? Well, I have 3 hydrogens on either end, so it's got to be a straight chain. So it's just going to be hexane. So all I have to do is count my carbons. So I'm going to start at 1. So that's 1, 2, 3, 4, 5, 6. Just drawing sticks. Go back and count them and make sure. 1, 2, 3, 4, 5, 6. Great. Okay, but I'm going to take my numbers off. You can't do that on the homework. Okay, C. We're going to go 1, 2, 3. Oh, and I'm just looking up here. I'm saying that's 10, right? That's 10. So it'd be decane, right? So let's do, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And look at your formula, right? That's 10. So if I have 10, it fits the CnH2n plus 2, which tells me it's a straight chain, right? Because if this number is 10 and I plug in 10 here, 10 times 2 is 20. To get to 22, I got to add 2 more. So it tells me it's a straight chain. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how many I needed. All right. Okay. And that is the end. Yeah, that is the end of section 2. You're all done. Have a great Mardi Gras.